Welcome to this tutorial. I'm solving paper 2-2 of May-June exam series of 2019. This is the theory paper of our O Level Physics syllabus 5054. So let's start the paper. Question number 1. It says, a student records the mass and volume of two irregular objects, one made of iron and the other of copper. So in the figure, we can see that there is a measuring cylinder and there is an electronic balance. One type of material is placed over here and the other type of material is placed here. The student uses the equipment shown in figure 1.1. Table 1.1 shows the results obtained. So for iron, the mass is measured in grams and the volume is measured in centimeter cube. The same two quantities are measured for copper as well. Part A, describe how to determine the volume of an irregular object with the measuring cylinder, and it is a 2-mark answer. Now for measuring the volume using a measuring cylinder, we always take some quantity of water initially in the measuring cylinder, and then we place the irregularly shaped object within the cylinder. So the level of volume is going to rise a little because of placing the irregular object. Now from the later reading, the initial reading is subtracted and the difference gives us the volume of the irregularly shaped object. So I'm going to write a 2-mark answer for this. Take some water in the cylinder and note its reading. The second point is place the object in the cylinder and note down the new reading. Subtract the later reading from the initial one. So we will get the volume of the irregularly shaped object. The next part says calculate the density of the iron. Now for calculating the density, we have the formula that rho or density is equal to mass upon volume. Now the mass of the iron, as we can see, is given to be 400 and the volume of iron is given to be 51 here. So this gives an answer of 7.8 grams per centimeter cube in two significant figures. So the final answer is 7.8 grams per centimeter cube. The next part says a third object which is also made up of copper has the same volume as the iron object. Calculate the mass of the copper object. So first of all, we are given with the volume of the object, which is 51 because it has the same volume as the iron, and the density of this object is going to be the same as the density of the copper. And for the copper, we have the mass of 350 and the volume of 39. So I'm going to write 350 upon 39, and the mass is the quantity that we have to find here. So these are the three things which are noted down as the data, and now we are going to use a formula and find the answer for the mass here. For finding out the mass, I'm rewriting the formula, making the mass as the subject. So this density is replaced as 350 upon 39. It is 51, and the answer comes out to be, the answer in two significant figures comes out to be 460 grams for this part. So I'm writing the mass as 460 grams. The next part says state and explain what happens to the density of the iron object when it is heated. So when we provide heat energy to any object, we know that it expands, and expansion means the volume of the object is going to increase, while the volume and density are inversely proportional to each other. So when the volume increases, the density decreases. So I'm writing density decreases as the volume increases. So this would be a 1-mark answer for this last part, and the question ends here with this part. The question is mainly related to the topic of pressure of our syllabus. The question says figure 2.1 shows a container of gas connected to a manometer. Here is the container of gas and it is connected to a manometer. The tube in the manometer has a constant cross-sectional area. So all of this tube has a constant cross-sectional area or uniform cross-sectional area. The gas in the container exerts a pressure. So the gas particles are exerting a pressure and pushing the mercury away. Define the term pressure So the term pressure is defined as normal force per unit area. And in the form of the formula, we can also write pressure is force upon area. The next part says the density of the mercury is 1.4 kilogram per meter cube. The gravitational field strength G is 10 Newton per kilogram. The atmospheric pressure, the pressure of the atmosphere is 1 into 10 raised to 5 pascals. And we have to find the pressure of the gas in the container, what it will be equal to. Now, the gas wants to escape from the container, but it is stopped by the mercury which is filled here. So whatever the pressure of the mercury is being exerted from this end would be the pressure of the gas which is present in the container. So the pressure of the gas in this situation is equal to the pressure exerted by the mercury. Now, mercury's pressure, since it is a liquid, could be calculated by using the formula rho GH. Rho is the density and it is given to be 1.4 into 10 raised to 4. G is gravitational field strength given to be 10, and the height of the mercury that we have to find using this figure. So we can see that the height of the mercury is at 16 at the moment, and the height is being calculated using the units of centimeters. So height of the mercury is going to be put as 16 but divided by 100 to convert it into meters. And the answer for this part in two significant figures is going to be 7.8 into 10 raised to 4 pascals. So the final pressure is 7.8 into 10 raised to 4 pascals here. Now the next part says in figure 2.1, the mercury level on the left hand side of the manometer is lower than on the right hand side. So on the left hand side, the mercury level is at 0. On the right hand side, it is equal to 16. The gas inside the container is heated. So gas molecules are going to get extra kinetic energy, and with that extra energy, they are going to exert larger pressure. This causes the mercury levels on both sides of to become the same. So because of the extra pressure, the mercury is pushed down by the gas from this level. So this level decreases and the level in the opposite end of the tube increases. This happens such that they become equal to each other. Determine the mercury level as shown on the ruler when this happens. So the difference is 16 at the moment, 16 centimeter. When this is going to go down and the same height is going to be gained by the other end of the tube by the mercury. So they will become equal to each other when the level reaches the reading of 8 centimeter in both the sides of the tube. So this will happen when the mercury has reached an 8 centimeter level. So I am writing the answer here as 8.0 centimeters. Now the last part says, explain in terms of the gas molecules what causes the level of the mercury to become the same. It is a 3-mark answer. So first of all, we have heated the gas particles. Because of that, I'm writing kinetic energy of gas molecules increases. So they hit the mercury molecules with larger force and more frequently. So the frequency of collision increases. Similarly, the force they were exerting will also be increased. This results in larger pressure being exerted on mercury. So that is why the mercury on the right hand side will move down. So mercury on the right side of the tube moves down and the mercury on the left side will move upwards. So this is why the level of the mercury is changing on both sides of the tube. So the question ends here with this part. The question is related to the topic of the light and especially the refraction of the light and the refractive index. The question says figure 3.1 shows 3 rays of light traveling in water from a light source S. So we can see in the figure there is water and this is the boundary after which the medium present is air. Within the water there is a source S and 3 rays of light. The first one, the second one and the third one is traveling within the water. Now, out of these three rays, one ray of light is totally internally reflected at the boundary between water and the air. As far as this ray is concerned, this is refracted, goes into the air, and not reflected back in the water. This ray, after being refracted, is traveling along the boundary, so it is also not totally internally reflected. While this third ray, we can see that when it hits the boundary of water in the air, it's not going inside the air. It is internally reflected within the water. So this is the third ray, what the examiner is talking about here. Now, part A on figure 3.1, mark the critical angle and label it as small c. Now, the critical angle, it is an angle of incidence, and all the angles are measured by the normal, and three normals are drawn here. As we can see, all these three dotted lines, they are called normal. So these are the imaginary lines which are drawn at the point of incidence, and they are always perpendicular to the surface or the boundary between the two medium. So the first ray, it is being refracted. The second ray, it is being refracted in such a way that the angle of refraction is becoming 90-degree, or the right angles here. So when a ray of light is coming from a denser medium like water and is entering into a less dense medium like air, so when the refraction happens, the ray of light always bends away from the normal. Like the first one, the ray was coming at a path of 25-degree with the normal, but it bends away from the normal and the angle of refraction becomes greater than 25, which is 34. So if we keep increasing this angle of incidence, there is going to be an angle for which the angle of refraction becomes 90-degree. So that particular angle of incidence is called the critical angle. What is critical angle? An angle for which the angle of refraction becomes 90-degree. The angle of refraction here is 90-degree. So this particular angle of incidence is called the critical angle. Okay. Now, the total internal reflection, which is happening in the next ray, is happening because the angle of incidence, when it increases or becomes greater than the critical angle, the ray is no more refracted into the other medium. So the ray of light, instead of going into the air, would be reflected back in the same medium, which is water. Okay. State why only one of the three rays is totally internally reflected. And the reason is its angle of incidence is greater than the critical angle. So since the angle is greater than the critical angle, the ray is totally internally reflected. The next part says calculate the refractive index of water. For calculating the refractive index, we have the formula n is equal to, or refractive index is equal to, sine I upon sine R. Since we have to calculate the refractive index of water, which means the ray of light is coming from a denser medium and moving into a less dense medium. So we have to be careful and change the values of angles here. Now remember, this formula is originally made when the ray of light or the light rays are coming from a less dense medium and they are entering into a denser medium. So in order to use this formula properly, the situation should have been like this, that the rays of light should have been coming from the air and they should have been entering into the water. So now, since this is not happening here, the situation given is opposite to this one. So we have to be careful here and change the formula or the values being put in the formula accordingly. So what I'm going to do, I'm going to put the angle which is being made in the water in place of R here. So since we have to find the refractive index of water, so the angle being formed in the water, that is going to be replaced in place of the angle of refraction, or the R, and the other angle would be replaced here in place of the angle of incidence. So in two significant figure, the answer of refractive index is 1.3, and I'm going to write this answer here in answer space, and the refractive index does not have any unit. Now to remember how to place the values, we can remind ourselves with a very short sentence or the trick that n and r should be of the same medium. So when we are replacing the values in this formula, we just have to make sure that the medium for which we are going to find the refractive index, or the medium of which refractive index we are using here, the angle being formed in that medium should be replaced in place of r. So everything will fall into its place automatically. The next part says the critical angle for the boundary between water and the air. So the next formula here, which is used, is another formula of refractive index, which is 1 upon sine of the critical angle. The value of refractive index we have just found. We are going to use it again here. So sine C is going to become 1 upon 1.3, which means critical angle C is going to be sine inverse of 1 upon 1.3, and the answer we are getting is 50.3 degrees, which in two significant figure will be written as 50 degrees here. So the question ends here with this part. The question is related to electromagnetic spectrum and the waves topic of the syllabus. The question says a star emits electromagnetic radiation over a range of wavelengths. It means the radiation being emitted by the star, they are not consisting of a single wavelength radiation, they have a range of wavelength. Figure 4.1 shows the brightness of radiation from the star at different wavelengths. So in the figure, we can see that at a few wavelengths, the brightness is quite large or higher, and in other wavelengths, the brightness of the light is decreasing. Okay. Radiation from the star is brightest at one wavelength. Determine the wavelength where the radiation is brightest. Now for the brightness, we are going to see the level of the y-axis, and we can see that the brightest wavelength is here. So we are going to match this point with the x-axis and find the value. So as you can see, I've made a dotted line on the graph, and it is being connected on the x-axis at a value of 1.2 10 raised to minus 6 meters. So this is where the brightness of the radiation is brightest according to the given graph, and the same answer is going to be written here, 1.2 into 10 raised to minus 6 meters. Visible light has a wavelength between 4.0 into 10 raised to minus 7 meters and 7.0 into 10 raised to minus 7 meters. So now we are talking about the visible light, and the range of wavelengths in which the visible light's colors are falling are given by these values. Now remember, visible light always consists of 7 different colors, which is Roy Gibbif, red, orange, yellow, green, blue, indigo, violet. And this is the sequence of color when the wavelength is gradually decreasing as we go from left to right. So the largest wavelength is of red color and the smallest wavelength is of violet color. Now here in the question, initially we are given with the smallest wavelength, which is 4.0 into 10 raised to minus 7, and then the largest wavelength is written here. So it means that the smallest wavelength is going to be of violet color, and the largest wavelength here written is going to be of the red color. It means that the sequence of color for this particular range of wavelength is going to be like this, which is the phrase VIBGYOR: violet, indigo, blue, green, yellow, orange, and red. Okay. The radiation in part A lies just outside the visible part of the electromagnetic spectrum. Now after the red, the outside part, just outside part of this spectrum is going to contain the radiations of infrared radiations. State the name of the region of the spectrum that contains the radiation in part A. So I'm going to write infrared radiations. Determine the frequency of the radiation in part A. The speed of the light is 3.0 into 10 raised to 8 meters per second. So we are given with the two quantities. The first thing, we have already found the wavelength, which is 1.2 into 10 raised to minus 6 meters. And the speed of the light is 3.0 into 10 raised to 8 meters per second. And now we have to find the frequency. The formula which connects all these three values, I'm going to write it down here. V is equal to F lambda. So the frequency is going to be speed divided by lambda, which means the value of speed is going to be 3.0 into 10 raised to 8 divided by 1.2 into 10 raised to minus 6. The answer in two significant figures form we are getting is 2.5 into 10 raised to 14 hertz. So in the final answer space, I'm going to write 2.5 into 10 raised to 14 hertz as the final answer for this part. So this is how a 3-mark calculation question should be attempted. First, we have to write down the relevant formula. Then we have to plug in the values, and the final answer should be written in two significant figure. And if the unit is not written there, we have to also write the correct or appropriate unit for our answer. So the question ends here with this part. The question is related to the topic of static electricity of the syllabus, and the question says in part A, figure 5.1 shows part of a machine used to investigate electrostatic charging. Before the machine is switched on, the metal dome and the ball are uncharged. So we can see that there is a machine and it contains a belt which is going to move like this on the two pulleys. Then there is a metal dome which is connected to the belt, and there is a metal ball placed besides the metal dome which is placed on a conducting rod, and it is also grounded here with a wire. When the machine is switched on, the metal dome becomes negatively charged. So by putting on the machine, we are going to make this metal dome as negatively charged. Explain how charging the dome causes the metal ball P to become positively charged here. So this metal ball is going to gain a positive charge when the metal dome becomes negatively charged. The phenomena which is going to happen here is that the negatively charged surface of the metal dome is going to repel the electrons in the metal ball surface. So the electron of the surface are going to move away, and since there is a connection to the ground being made by this earth wire, so the electrons would move to the ground or the earth because of the repulsion being caused by the metal dome negatively charged surface, and this is going to create a deficiency of electrons on the surface of the metal ball. So the metal ball surface is going to gain a positive dominating charge here. So this is how the metal ball is gaining a positive charge, and we have to write a 2-mark answer for it. So the first point I'm writing is electrons experience a repulsive force from the metal dome. So they move to earth, and a positive charge is induced on the metal ball. So for a 2-mark answer, these 2 points are important. The electrons are experiencing a repulsive force, and then they are moving to the earth. So these 2 points are going to earn us 2 marks for this particular question. The next part says a photocopier works using electrostatic charging. It contains a drum whose surface conducts charge where it is exposed to light. So this is the drum that we are talking about. The place where the light is going to fall on the drum, it is going to conduct the charge. Figure 5.2 shows a piece of paper. This is the piece of paper which is going through the machine, the drum already mentioned, and the heater of the photocopier. This is the heater which is present after the drum. The photocopier produces a copy of an original page on a piece of paper. The sentences below describe the process of making the copy, but the sentences are in the wrong order. Arrange the sentences in the correct order. The first and the last sentences are already in the correct boxes. So the procedure starts with sentence A. The drum is given a positive charge. So when it is positively charged, the next thing which is going to happen is an image of the original paper is projected onto the drum. So I'm going to write a D over here. The image of the original paper is projected onto the drum. Then the next thing, where the light hits the drum, when the image is projected, the light is going to hit certain parts of the drum. Where light hits the drum, the positive charge leaks away. So this is going to be the next step. The positively charged parts of the drum attract a black powder. So the powder is going to move towards that. And the last thing, the drum rolls against a piece of paper, transferring powder to the paper. Okay, and the last is the paper is heated, which makes the black powder stick to it, which is already done here. So this is the sequence in which the photocopier is going to work. The question ends here with this part. The question is mainly related to the topic of electric circuits. The question says 2 lamps P and Q are connected to a battery of electromotive force EMF 6.0 volts. So these are the 2 lamps. The symbol of lamp is very clear here. They are connected to a battery of EMF of 6.0 volts and an ammeter. This is the ammeter as shown in the figure 6.1. Now, by seeing the circuit, it is obvious that the 2 lamps are connected in parallel configuration, and the current which is going to flow through the circuit is going to pass through the ammeter. So the total current flowing from the battery is going to be given by the ammeter. Then when the current reaches this particular junction, it is going to divide into two parts. Some of the current is going to go through the lamp P, and the other, or the remaining current, is going to go through lamp Q. The next part of the question says lamp P has a resistance of 15 ohms. So this particular lamp has the value of resistance as 15 ohms. Now remember, in a parallel circuit, the voltage of each branch is same as the voltage source or the EMF source. So the voltage of this branch is going to be 6.0 volts, and the voltage of the second branch is also going to be 6.0 volts here. Okay, calculate the current in lamp P. Now for calculating the current in lamp P, we are going to use the relation V is equal to IR, which means current I1 is going to be equal to V1 upon R1. The voltage in all the branches is same as the EMF source, which is 6 volts, and the given value of the resistance is 15. So the answer in two significant figures is going to be 0.40 amperes here. It means the current flowing through this particular branch is 0.40 amperes out of the total current which was given to us as 0.65 amperes. The ammeter reading is 0.65 amperes, so the total current is 0.65 amperes. Calculate the resistance of lamp Q. Now we have to calculate the resistance of this lamp. Now it is obvious that the current flowing through this lamp is going to be the difference of 0.65 and 0.40. So the current of 0.25 amperes is going to flow here. So first thing, I'm going to write the amount of current flowing through it, and it is going to be the total current minus the current I1, which is 0.40. So the answer is 0.25 amperes. Now the resistance could be calculated by dividing the voltage with the current. The voltage is still going to be the same, which is 6.0 divided by the current of 0.25 amperes, and the answer is 24 ohms. So the answer in two significant figures is 24 ohms for this part. The two lamps are now connected in series to the ammeter and the same battery. Now instead of the parallel connection, they are now being connected in series with the ammeter and the same battery. In the space below, draw the circuit diagram. So we are going to start with the battery. Okay, so now I've drawn a battery of 6.0 volts here. This is the ammeter, which is connected in the circuit. This is the lamp P. This one is lamp Q. And now the two lamps are connected in series with the same ammeter and the same battery. Explain why the ammeter reading is less than 0.65 amperes when the lamps are connected in series. So the obvious reason is when the lamps are connected in series, the total resistance being offered by the lamps is going to be much higher than the total resistance which was being offered when they were connected in parallel. So when the lamps were connected in parallel, their total resistance is the sum of the reciprocals, 1 upon 15 and 1 upon 24. So the total resistance here, now it was 9.2 ohms here, and when the two are connected in series, the total resistance has increased to 39 ohms. So whenever a larger resistance is connected to a battery, lesser current is drawn from the battery, and when smaller resistance are connected to is connected across a battery, obviously the battery is going to deliver more current. So I'm going to write the total resistance has increased. This is why the value of current has decreased when the two lamps have been connected in series. The question ends here with this part. This question is related to the topic of motor effect or the DC motors of our syllabus. The question says figure 7.1 shows a copper wire placed on two copper rods in the magnetic field between the poles of a magnet. So the author or the examiner is describing this copper wire, which is placed on these two copper rods, and the copper wire is placed between the poles of a magnet, the north pole and the south pole. Now we can see that there the copper rods are connected to crocodile clips, and those crocodile clips could be further connected to a battery. The crocodile clip A touches the positive terminal of the battery. This causes the copper wire to move. On figure 7.1, mark with an arrow the direction of the current in the copper wire. Now, since the crocodile clip A is going to touch the positive terminal of the battery, so the conventional current is going to flow from this end through the copper wire and then going to return from the other copper rod to this crocodile clip B. So the direction of the current in the copper rod is going to be like this. It is going to enter from this terminal and going to go out from the other terminal. The next part says explain why the copper wire moves along the copper rods, and we have to answer this question for 2 marks. So the phenomena which happens here is that as soon as this crocodile clip is connected to the battery, the current starts flowing through the copper wire. Now this current which is flowing through the copper wire, this creates a magnetic field around the copper wire. And secondly, the current is also perpendicular to the magnetic field lines. So whenever a current flows perpendicular to magnetic field lines, there is interaction between the magnetic field lines of the current and the magnet. So both magnetic fields are going to interact, and the conductor is going to experience a force, and that force actually moves the wire in a particular direction. So for a 2-mark answer, I'm going to write current in the wire creates a magnetic field around the wire. And because of this, there are 2 magnetic fields now. One magnetic field from the magnet and the other magnetic field because of the flow of current. The magnetic fields of magnet and current interact and the wire experiences a force. That is why the wire was moving. Name the 2 different devices that use this effect. So this effect is obviously used in DC motors, and similarly we could also write the name of the device of loudspeaker, which works on the same principle. There were 2 marks and we have to mention 2 devices here, 2 different devices. So the question ends here with this part. This question is related to the topic of CRO, the cathode ray oscilloscope. The question says figure 8.1 shows a device that is used to show the force on an electron in an electric field. So the device has a filament over here. Then there is a positively charged metal cylinder, which is called the anode. Then there are 2 horizontal metal plates, and each plate could be connected to a different terminal for creating an electric field between the horizontal metal plates. Then all of this is placed in a tube, and there is vacuum, so no air present here. Now this dotted line is showing the movement of electrons, how it happens in this tube, and there is a screen over here where the scintillation made by the electrons could be seen. Now the first part says explain how a continuous flow of electrons from the filament is produced in this apparatus. For the continuous flow, we do 2 things. Number 1, this filament is heated and it is connected to a battery over here. because of which a large current flows through the filament and the filament gets heated, so the electrons emit from the filament through a process which is called thermionic emission. Then secondly, when the electrons emit from the filament, they are attracted by this positively charged anode, and by attracting these electrons, the anode accelerates the electron and forms a continuous beam of electron being generated from the collaboration of these two components in the device. So for a 2-mark answer, first I'm writing filament is heated and it emits electrons. This is the first thing that happens, and it emits electrons due to thermionic emission. The second thing is the cylindrical anode attracts these emitted electrons and accelerates them. Because the anode is positively charged and there is an electrostatic force of attraction, so electrons are attracted towards the anode, and this attraction causes them to move quickly and accelerate them. The next part says when an electron is in an electric field, there is a force on the electron. Electrons experience a force of attraction from positive terminal, and they experience a force of repulsion from the negative terminal. The direction of this force is in the opposite direction to the electric field. Now it means that, for example, there is a plate which is connected to the positive terminal, and then there is another plate which is connected to the negative terminal. So the field lines are going to be from positive to negative. This is the direction of electric field present between these two plates. Now when an electron enters this field, what happens? It is attracted by the positive terminal. So it experiences a force upwards because of this attraction, and it is repelled by this negative plate. So that again exerts a force in upward direction. So the direction of force being experienced by the electron is upward, while the electric field's lines direction, they are directed downwards. So they are in opposite direction. So I'm reading it again. The direction of the force is in the opposite direction to the electric field. Describe how the metal plates in figure 8.1 can be used to show this. Now, in order to show this, the electron beam is generated from the filament. So electrons are passing through the region which is present between the plates. We have to connect these two plates with terminals of a battery. So one of the plate is going to become positive and the other one is going to become negative. So now the electrons would show deflection. The field is directed downwards, but the force being exerted on the electron is upward, and the direction of deflection would show that they are being deflected in the upwards direction. So again, it is a 2-mark answer, and I'm going to write 2 valid points for this. The first point I'm writing is the metal plates are connected across a power source. This is the first thing which is going to create an electric field between the plates. When electrons pass through the region between the plates, they deflect away from negative. They deflect away from negative, while field is from positive to negative. So the direction of deflection is against the direction of the electric field present between the plates. So this is how we can answer this question, and the question ends here with this part. This question is related to the topic of kinematics of our syllabus. So the question says figure 9.1 shows a map of the route taken by a car as it travels from town A to town B. Now this is the figure 9.1. Town A is shown by this point here. Town B is here on a grid. Now this is the direction of north and this direction is east. Scale says the side of one square is 5 kilometers. So every side of these squares is representing a distance of 5 kilometers. The journey involves a distance and a displacement. The distance is calculated by measuring the length of this line, and this would give us the distance between the two towns. And the displacement is going to be the shortest distance between town A and town B. Using the scale on figure 9.1, determine the displacement in traveling from A to B. Now, if we want to determine the displacement, we have to find the shortest distance between the two towns, the size of displacement. And similarly, for the direction of displacement, we have to find the angle at which the displacement is covered. Though, firstly, I'm going to connect town A and town B with a straight line to show the shortest distance between the two towns. So this is the shortest distance between the two towns, town A and town B. I have connected town A, town B with a straight line to show the displacement between the two towns. Now, in order to calculate this distance, I can see that there is a horizontal component of the displacement and there is a vertical component of this displacement. And when I join these two, I get a right angle triangle here. Now, the distance covered horizontally, or the displacement covered horizontally, is 10 boxes, and each box is representing 5 kilometers. So 50 kilometers is the distance in horizontal direction, while in vertical, we can see that there are 3 boxes multiplied by the 5 kilometer shown by each side of the square. So the vertical distance is 15 kilometers. Now, if I apply Pythagoras theorem here, which says hypotenuse square is going to be equal to the sum of opposite square and adjacent square. So the displacement is going to be equal to the square of 15 and the square of 50 within the square root. So this is how I can calculate it. So I'm writing the size of displacement is equal to the square root of square of 50 and the square of 15. So this will become 2500 plus 225, which gives 2725 within the square root. And the answer of square root comes out to be 52.2, which in two significant figures could be written as 52 kilometers. So the size of displacement is 52 kilometers here. Now, for the direction of displacement, the direction could again be found by using the same right angle triangle. And for the direction, I'm going to find this angle theta. So I'm using the ratio tan theta, which is opposite upon adjacent. Opposite is the side which is present in front of the angle theta, it is 15, and adjacent side is 50. So for this angle theta, I am going to take the tan inverse of 15 upon 50. Now this theta comes out to be 16.69 degrees, which is 16.7 degrees, or I could also write it as 17 degrees. Now the direction of displacement, the directions are normally measured from North Pole. So this gives us the bearing of a vector also. So since this angle is 17 degrees, so I'm going to subtract it from 90 to find this angle, which will give us the direction of the displacement. So I'm writing it is 90 degree minus the tan inverse of 15 upon 50, which we got as 17 degrees. So 90 minus 17 degree gives us the value. It gives us the value of 73 degrees. So the direction of displacement is going to be 73 degrees here for this part. The next part says state how distance differs from displacement. So the difference is that distance is a scalar quantity and it does not have any direction. So I'm writing distance has no direction, while Displacement is a vector quantity, and it also has a direction. In some parts of the journey, the car is traveling at a constant speed. The speed of the car is constant, means the magnitude of velocity is not changing, but is also accelerating. Still, the car is accelerating, means there is a change in velocity. And if the magnitude of velocity is not changing, then the only way the velocity is going to change is that the direction of velocity or the direction of motion is going to be changing. Explain how this is possible. So it is possible when the car changes direction of motion. So the velocity changes as the velocity depends on direction. So when the velocity is going to change, the object is going to have an acceleration. At town B, the car makes an emergency stop. The total stopping distance of the car is the thinking distance added to the braking distance. So this is also the definition of the stopping distance, that it is the sum of thinking distance and the braking distance. Describe what is meant by the thinking distance. The thinking distance is the distance traveled when the driver sees a hazard and starts to apply the brake. The distance covered between these two events is called the thinking distance. So I'm writing distance traveled between seeing a hazard and applying the brakes. Whatever distance is covered between these two events is called the thinking distance. The brakes on the car work badly. This increases the braking distance. State two other factors that increase the braking distance. So there are many other factors. The two could be poor tire surfaces. They are too used or have become smoother and not producing enough resistance. The other could be poor road conditions. They could be wet or greasy. So that is why the braking distance has increased. The mass of the car and the driver is 1200 kilograms. Just before the brakes are applied, the speed of the car is 30 meters per second. So here we are given with the two quantities, the mass of the car and the driver, and similarly the speed at which they are traveling is 30 meters per second. Calculate the kinetic energy of the car and the driver just before the brakes are applied. For the kinetic energy, we have the formula that it is equal to half mv square. So I'm going to replace the values, 1200 for the mass and 30 for the speed. So it gives the answer in two significant figures as 540,000 joules. So in the answer space, I'm going to write 540,000 joules here. For a 3-mark question, it is important to write down the formula, plug in the correct values, and then write the final answer in two significant figure with appropriate unit. The braking force that stops the car is 1800 newtons. So with this force, the car is going to be stopped. Calculate the deceleration on the car. Now, for acceleration or deceleration, we use the formula A is equal to force divided by the mass. The force is 1800 newtons, and the mass of the car and the driver combined is 1200. So the answer comes out to be 1.5 meters per second square. So the deceleration with which the car is stopping is 1.5 meter per second square. Explain why the temperature of the brakes increases during the braking system. During the braking. Explain why the temperature of the brakes increases during the braking. So during the braking, there is a rubbing of two surfaces together and there is friction between the two surfaces. So the energy is converted to thermal energy. So I'm writing the friction produces thermal energy. That is why there is the temperature change in the brakes. So the question ends here with this part. The question is related to the thermal energy section of the syllabus. It says figure 10.1 is a diagram of a soldering iron. Solder is a mixture of metals used to make a permanent contact between electrical wires. The heating element raises the temperature of the metal tip. So there is a heating element in the soldering iron, and it increases the temperature of this metal tip when solder is placed against the tip. So for example, there is a piece of solder and it is placed against the metal tip. The solder melts over the wires to be joined. So there are two wires, for example, we have connected them. So when the solder melts on the wires, there is a stronger connection between the wires because of the melting of the solder. When the solder cools, it solidifies and the permanent connection is made like this. The working temperature of the metal tip is 380 degree centigrade. So the metal tip is operated at a temperature of 380 degree centigrade. The boxes in figure 10.2 show two materials. One is metal of the material tip and the other is solder, and some different melting points. So there are different given melting points. On figure 10.2, draw a line from the metal of a metal tip and a line from the solder to a suitable melting point for each. Now, solder is something which should be melted below this working temperature of the metal tip, because metal tip normally operates at 380 degrees centigrade. So solder must have a melting point before this, so that when the solder is brought near the metal tip, it gets melted. And when it melts, then it could be connected to the wires which we are trying to join. So suitable temperature for the solder would be 200 degrees centigrade. If we take this temperature at 380 degrees centigrade, then obviously it is not going to melt properly. And if we are going to take it higher than this, then it is not going to melt at 380 degrees centigrade. Similarly, taking a lower temperature is also not suitable. For 20 degrees centigrade, the solder is already melted under normal room conditions or temperatures when we are trying to join or make a permanent connection, and it is not going to solidify. And when it is not going to solidify, the permanent connection is not going to be made. Similar is the case for 0 degree centigrade. So the only suitable choice for solder out of the given temperatures is 200 degrees centigrade. Similarly, the metal of the metal tip should have a melting point much higher than the 380 degrees centigrade at which it is normally operated. So the temperature or the melting temperature of the metal tip itself should be much higher than that value. The next part says the heating element is rated at 24 volts, 3.3 amperes. So this is the rated voltage and the current reading of the heating element. The heating element is switched on. The temperature of the metal tip rises from 20 degrees centigrade to 320 degrees centigrade in the first 10 seconds. Calculate the electrical energy supplied to the heating element in the first 10 seconds. The electrical energy is calculated by the formula E is equal to VIT. The voltage across the heating element is 24. The current flowing through is 3.3 and the time is 10 seconds. The answer in two significant figures is going to be 790 joules here. So this much electrical energy is supplied to the heating element in the first 10 seconds. The metal tip is made of copper and has a mass of 2.3 grams. This is the mass of the metal tip. The specific heat capacity of copper is 0.39 joules per gram per degree centigrade. Calculate the thermal energy or the heat gained by the metal tip in the first 10 seconds. During these first 10 seconds, how much thermal energy is being gained by the metal tip? Now, heat energy gained is given by mc delta theta. The mass of the metal tip is given to be 2.3 grams. The specific heat capacity is 0.39 joules per gram per degree centigrade, and the change in temperature was from 20 to 320. So the change in temperature could be calculated by the difference of these two values, and the final answer in two significant figures is going to be 270 joules here. So the thermal energy gained by the metal tip is going to be 270 joules. Now it is a 3-mark question. We have to write down the formula, plug in the correct values, and then write the final answer in two significant figures. The next part says describe in terms of free electrons the process by which heat transfers through the metal tip. Since it is a metal or copper, so it contains free electrons, and those free electrons are able to move through the metal and they transfer energy from the hotter region to colder region. So I'm writing free electrons move around the metal tip and pass on thermal energy to other parts of the metal tip by colliding with the atoms or other electrons. So this is how these free electrons or mobile electrons play a vital role in transferring the thermal energy throughout the metal. The next part says heat is lost from the metal tip by convection in the air. Explain how the convection occurs in the air. So for the convection, the air particles which come in contact with the metal tip, they gain energy, and since they become hot or heated up, their volume increases, they expand, they become less dense, and then they start rising. So when the hot air rises, the colder air comes down and replaces them. So I'm writing, it is a 2-mark answer. The first point I'm writing is the air particles gain thermal energy and become less dense, so they rise and are replaced by cold air particles which are more dense. Because their temperature is lower, they are not that much hotter or heated up, so their density is larger, they come down and replace them. The next part says the temperature of the metal tip is measured with a thermocouple. Thermocouple is a type of thermometer which consists of two different wires, and using those two different wires we make two junctions, and a voltmeter is connected to one of the wires. In the space below, draw a label diagram of thermocouple. Mark with the letter H the part of the thermocouple that is placed on the metal tip. For making a thermocouple, we need two different wires, and in one of the wires, a voltmeter is to be connected. So first of all, I'm making a voltmeter. So this wire with the voltmeter will have two ends. There is a second wire which is connected to the first wire, and these two wires are of different materials. Then the first junction is placed in a beaker of melting ice, so that on the one end of the junction of wires we know a fixed and lower temperature. So this is a beaker which contains melting ice at 0 degree centigrade, and here at the other end we are going to place this junction on the metal tip, for which we are going to note down the temperature. So this is how a thermocouple works. It consists of two different metal wires, and in one of the metal wire we connect a voltmeter, a very sensitive voltmeter. Then there are two junctions made by joining these two wires. One of the junction has to be kept at a place whose temperature is known to us and should be a lower temperature, like the melting ice at 0 degree centigrade. And the other junction is placed on a object or the substance for which we are trying to note down or find its temperature. So I've marked it with the letter H. This one would be placed on the metal tip. The next part says state two reasons why a thermocouple thermometer is suitable for measuring how the temperature of the metal tip varies during first 10 seconds. So there are two very important characteristics in a thermocouple thermometer. Number one, it can measure large temperatures as compared to the clinical thermometer or the laboratory thermometers, which are not able to measure very high temperatures, and and they simply get damaged when very high temperatures are measured using them. Similarly, the second thing is it is very responsive. By responsive, we means it can measure very little change in temperature in very little time. The normal laboratory thermometers or the clinical thermometers, they need some time to respond to the temperature changes. And similarly, for very little temperature changes, they are not very responsive. On the other hand, thermocouple thermometers have this property that they detect very little changes of thermometer and they detect them very quickly. So they are called very responsive. So the question ends here with this part. The question mainly relates to the section of nuclear physics of the syllabus. Stars are formed inside a cloud of gas and dust in space. When a star forms, the cloud first becomes smaller as it collapses. State what causes the gas cloud to collapse. It collapses because it is being pulled by a very strong force of gravity in the core of the star. So we can say that the force of gravity causes it to collapse. Eventually, nuclear fusion occurs in the star. State two conditions required for nuclear fusion to occur in the star. So the first condition is we require very high temperature for the fusion to start because there are strong forces of repulsion between the nuclei and they have to be overcome by this high temperature condition and high pressure condition. Then the nuclei would be able to fuse together and the nuclear fusion could occur. When a large star explodes, nuclei of heavy elements are formed. One such nucleus is uranium-235. State the name and the number of each type of particle found in one nucleus of uranium-235. So there are two main particles in the nucleus. One is proton, and as we can see from the element notation, they are 92. The other particle is neutron, and it is the difference of 235 and 92. So it will be 143 in number. State one feature that is the same for the nuclei of all the isotopes of uranium. So when we are talking about the isotopes, they all have same number of proton, but different number of nucleons. So here they are asking about the similarity, the feature which is same. So I'm writing they all have same number of protons. A nucleus of uranium-235-92 in a nuclear reactor can undergo nuclear fission. Describe the process of nuclear fission in a nuclear reactor. So the fission starts when a neutron hits the nucleus of a uranium and it is temporarily absorbed by the nucleus, which creates a greater instability within the nucleus, and then the nucleus splits up and more neutrons are formed, releasing high amount of energy. So I'm writing neutron hits the nucleus of uranium and is absorbed by the nucleus, which then splits up to form smaller nuclei and emits more neutrons. So this is the process that occurs when the nuclear fission is happening. State one difference between nuclear fusion and nuclear fission. So in fusion occurs when smaller nuclei join together, while in fission larger nucleus splits up. This is one main difference between the two processes. The nucleus of uranium is not stable. It decays by emission of an alpha particle into a nucleus of thorium, Th. Complete the nuclear equation that represents this decay. For alpha, the proton number is 2 and it is written. The nucleon number for alpha is 4 because it consists of 2 protons and 2 neutrons. Now for the thorium, the proton number is going to decrease by 2, so that 90 plus 2 becomes 92, and the proton number is going to decrease by 4, so it will be 231 for the thorium. The next part says Giger and Marsden carried out an experiment to investigate the scattering of alpha particles. Figure 11.1 shows a diagram of the apparatus that they used. So they used radioactive source, They created a beam of alpha particles. They placed a thin gold foil, and there was a fluorescent screen all around, and there was a vacuum within this space. When an alpha particle strikes the fluorescent screen, a flash of light is emitted. On figure 11.1, mark with the letter P where most flashes occur on the screen. So most of the alpha particles, they were able to pass straight through the screen. So we can mark P right behind the gold foil because most of them, they went straight through undeflected. Describe what is seen on other parts of the screen. So on the other parts, few flashes were seen. Most of the flashes were seen right behind the screen. State two conclusions about atoms of gold that resulted from this experiment. The first conclusion was most of the atom is empty space because most of the alpha particles were able to pass straight through. Number two, nucleus is massive and positively charged. And this was concluded because very few alpha particles were showing smaller or larger deflection. So mass is concentrated within the nucleus and the positive charge is also concentrated within the nucleus. So these were the two or three main conclusions from the experiment. And the question ends here with this part.